Hello guys, this is Subeko, and today we are going to learn something new. And the interface you see here is the Tinkercad interface. The Tinkercad is an online simulation tool, and they use it for designing embedded systems. So we are going to use this online simulator to design a new system. And the system that we are going to design is a smart home security system. So this is a description for the system. So we are going to read through it and see and understand the components that we will need to design it. So the system says, design an embedded system that detects door open and close states, and then it also monitors motion inside a restricted area, and then the system should activate alarm status LED when the door is closed, and alarm LED when motion is detected while the door is open. So looking at this description, we will be able to point out the requirements or the components or the devices that we want, and we connect together so that we come up with a system. So let us go back to the components area. So the first device that we want is the microcontroller, which is the main board. And then secondly, we will need a sensor that is called the PIR sensor. So this is it here. And then we also need a slide switch, and this is the slide switch. We shall place it there. We will also need an LED, a red and a green LED. Okay, so we also need resistors. We shall put this here for each LED. So let's change this to green. Okay, like that. So now these are the components that we need for the system. So we will start connecting them together. We connect all of this system to the main board, which is the Arduino. So let us start with the slide switch. So we shall take this terminal 1 and we connect it to the 5V voltage on the microcontroller. So we pull it here. We find the 5V pin here. So as you can see, it is indicated in 5V, so that is the voltage for it. So we connect it there, and then the one in the middle, which is the common one, is named as common. We have to connect this to digital pin 2 on the microcontroller. You can choose any pin, but for our case right now, we shall use digital pin 2. And then the last one, which is terminal 2, we can connect it to the ground on the microcontroller. So here we find ground. There, we connect it there. So now we are done with the switch. So we can now start connecting the sensor. Let us change the wire. Let's change it to red. So for the PIR sensor, the signal pin goes to digital pin 3. Yeah, this is a signal pin. We shall take this to digital pin 3 on the microcontroller. So this is digital pin 3, we connect it there. Okay, and then the middle one, which is called the power, we connect it to the voltage 5, which is the 5V. We connect this there. And then the last one, which is the ground, this one is always connected to the ground pin there. So we are done with the switch and the sensor. So the next part, we are going to connect these LEDs. So for us to connect this, let us first change the color. For the red one, let's use any blue. So we connect the anode. Let's connect this anode to this terminal pin 2. And then this, we also connect it to terminal pin 2. So for the green, let us take the green and we connect it to digital pin 4. Okay, and then for the red, let's connect it to digital pin 5. And then both of these LEDs, we connect the left pins to the ground. Okay, we connect all of them to the ground pin. Yeah, there. So now we are done with the connection for all the components. And next we shall go to the code. I have the code ready, so I will just go through them and explain what they do. So here we have here we define our pins. So these numbers here, they are the same numbers that we used here on the microcontroller. Those are the digital pins that we used. So we used pin 2 for door switch, pin 3 for PIR sensor, and then the green LED on pin 4, then the red LED on pin 5. So we made this variable constant so that they don't change. And also we defined other two variables here for a door state and motion state. So for the door state, we use it to store the status of the door, and for the motion state, we use it to store the status of the sensor. And then next we have this loop. So here we initialized our output pins. So this is for the LEDs, the green and the red LEDs. So we set it to be an output for both of the LEDs. So we need to see output from these devices, the red light and the green light. And then also we initialize the input pins, which is the door and the sensor. So here we use pull up input for the switch. So this means logic low, which is 0, and this means switch is connected to ground, and also the door is closed. And then logic high means 1, and that actually means switch is opened and the door is actually open. Okay, so on this line 43, 0 begin. So we we tell the computer to open the internal monitor so that we see what's happening to the system. So this is a serial monitor down here. Let me toggle it. So this is what we want to see, what's happening to the system. We want to see something like this. So, but the text that you see, we shall come and see it later. Yeah. So the 9600 actually means the speed, and this is measured in bits per second. And then under the void loop, here we read the sensors. So the door state and the motion state. So we want to read the door, and we also need to read the sensor. So here it reads the pins for the door, and it also reads the pin for the sensor. Then under here, this line 51 to 54, this is what we want to see in the monitor. We want to see what is happening to the system. So we print out the text door, okay, and then followed by the text closed and the text open. So when do we want to see closed? So we want to see the text closed when the door state is low, meaning if the door is closed, we want to see this text. Otherwise, we will need to see the open text. And the same thing applies to motion. We want to see this text motion. And when the motion is high, meaning if there is motion being detected, we want to see this text that motion is detected. Otherwise, we want to see none if there is no motion. So now we come to our logics. Logic 1 says we need a normal status LED when door is closed. So here we will use an if statement. So we say if the door state is low, we want to see a green light, and we need to maintain the red light to be low. We want the red light to be off. So meaning if the door state is closed, we need the green light to turn on, and the red light should be off. Else the green light should be off. And secondly, if there is motion, we need the green light to be on. We need to turn on the light, the red light on when there is motion, if motion is being detected. Otherwise, we don't need to see that red light. It just has to be off. And here we need to set a delay of 0. So 0 means we don't need a given time when motion is being detected. So this actually means after what time do we need the light to turn on or to turn off after motion is being detected. So for our case, we set it to be 0 because we want the light to just turn on immediately after motion is being detected. So this takes us to the end of our code. So the next thing that we will do now is to test it. We start the simulation and see the output for the system. Okay, so we have a button here, the start simulation. This is where we click on it and see whether the system is working or not. So let's do that. Let's click on this. Okay, so if you come down here on the monitor, you will see that the door is open, but there is no motion. Okay, you see this text door, and it is opened, but there is no motion. The motion is none. Okay, so let's click on the switch. We toggle it to be off. Okay, so the door is now off. Let's see the monitor. what it says. So the door is now closed and there is no motion. Okay, so let's use the sensor. Let us turn it, and you can also see the green light turning on since the door is closed. So let us open the door and see. See, the door is opened, but there is no motion. So let us use the sensor and make it detect something. So we click on the sensor. Okay, we click on the sensor. So for it to send something, we need to bring our cursor on this green circle and we move this around. See that? So now the motion is being detected and the red light is on. You can see on the left, the red LED is being turned on because the door is opened and there is motion being detected. You can confirm this from the monitor. See, there is motion, the door is opened and there is motion. Okay, so you click on it again, the red light is on, and under the monitor you can see that the door is opened and motion is being detected. If you leave it for some time and the motion is no longer being detected, since there is nothing being detected there and the door is still open, so you can still turn off the door, and it tells you that the door is closed and there is no motion. So if the door is closed and there is motion, still the green light will be on. The red light only turns on when there is motion and when the door is open. So that is how the system works. And like this, we have completed our home security system, and it is now working It is now working perfectly. So this brings us to the end of our first embedded system, which is the home security system. And I would like to say thank you for watching.